Hello everyone, welcome back to the Blockman editor tutorial. In these videos, we will give you a complete introduction to the Blockman editor. In this video, we will introduce the sliding joint constraint and weld all constraint. First, let's look at the scene in the video. When the entity pushes the car will move forward in a straight line for a certain distance. And when the entity pushes the car from the other side, the car will go backward in a straight line to the original position. The car in this scene is created using the weld all constraint, while the sliding joint constraint achieves the forward and reverse effects of the car. We will first use the weld all constraint to complete the car. Enter the editor. Here we have already prepared the parts to make up the appearance of the car in advance. The head and tail of the car are made by subtracting two parts to create a union. The wheels are 4-cylinder parts. Adjust the position of each part. Select the 6 car parts in the Game Resources view, then click the Constraint button in the top menu bar to open the drop-down menu and select Weld All. Note that the first selected part will be the main part and will be welded with the other parts. At this point, some nodes appear below the main part in the Game Resources view. These are the constraints we just created. Click them to see which parts are welded. Now we have finished building the car using Weld All. If you want to achieve moving the car forward and backward, you need to use the sliding joint constraint. First, place a part in the scene as the floor. Adjust the size and check its anchor properties, and put the car we just built on the floor part. Next, click the Constraint button in the top menu bar to open the drop-down menu, and select Sliding Joint. You can see a dot following the mouse movement. This dot is the anchor point of the constraint. Add the anchor point to the car part. Then add the second anchor point that appeared after onto the floor part. This successfully creates a sliding joint constraint. At this point, a node will appear in the Game Resources view, and this is the sliding constraint we just created. The effect of the sliding joint is that the part will move in a straight line, under the constraints of the sliding joint. The line of anchor points is the trajectory of the movement. To implement this trajectory, it requires us to anchor one of the parts, and apply a force in the direction of movement to the part that needs to slide. Next, we modify the world coordinates of the anchor point, and adjust the anchor point to the appropriate distance. The coordinates of anchor points are categorized into relative coordinates and world coordinates. Relative coordinates are the position of the anchor point in the object coordinate system, and world coordinates are the position of the anchor point in the world coordinate system. Note that the world coordinate y-axis values of the two anchor points should be similar to prevent the part from moving before the force is applied. Finally, modify the maximum distance and minimum distance according to the anchor distance. Note that the maximum distance should be similar to the value of the anchor distance, otherwise, the position of the anchor point will change the position of the car. Click Save and enter the run mode. You can see that when the entity pushes the car forward at one end of the anchor point, the cart moves forward. When the entity pushes the car at the other end of the anchor point, the car backs up to its original position. By using the sliding joint constraint, we can also achieve other effects, such as the drop tower ride, launching firework effects, etc. If you are interested, you can try it yourself by checking out the user manual. That's all for this video. We hope it can help you on your way to becoming a great creator. If you want to know more about the editor, you can comment below the video or post on the official forum. See you in the next video.